Hello everyone, this video is going to introduce 5 main parts of optical switching. They are as shown on the slides: optical components, optical switching overview, or wavelength switching, wavelength routing networks, photonic packet switching, and dealing with contention. So firstly, the optical fiber will be introduced. It consists of core glass, gliding glass, and jacket plastic, which could help rays of light are confined to fiber by total internal reflection, and its benefits are good for insulating, immune to electromagnetic noise, broad bandwidth, low attenuation loss over long distance. As for the case of mismatching between fiber and transceivers, the solutions are using multiple optoelectronic system transceiver or receivers at different lambdas and wavelength division multiplexing. As for the second part is optical switching. Uh, so as for the optoelectronic networks, the advantages are simplest the use of optics to network merely involves replacing wire links with fiber. Wire link joint switch line interface card translates signal between optical and electronic forms, and the disadvantages are expensive optoelectronic parts are replicatable, and electronics limits switch throughput. But as for all optical networks, the benefits are high transmission speed, eliminate optoelectronics from networks, low net cost network, and environmentally friendly, which is lower power consumption, and the transparency, payload rate, and format can change without changing network elements. But actually, the costs are really expensive. We should add optical switching equipment, and as for analog, signals are amplified and not regenerated, and the error rate monitoring is so hard. So thirdly, let's see the all wavelength switching microelectromechanical systems. It can implemented on silicon using photolithography. It can process positioning of mirrors, and it can integrate mechanical system with control electronics. The density should advance with progress in photolithography technology. Then we move to the wavelength routed networks. With the optical demultiplexing is trivial. Combine signal by splicing fiber together. As for the optical demultiplexing, uh, is dropping wavelengths, and as for optical multiplexing is adding wavelengths. So then let's focus on the static demultiplexing, which is physical configuration assigns lambdas to ports, generally require precise physical element. It can be achieved by using refraction, diffraction, interference, and the interference filters. It has good thermal stability but high loss, such as yellow wavelengths that is reflected many times. And the next, the interferometer filters or gates. Controllable delay element determines relay phase of combined wavelengths. So the fourth part is the photonic packet switching. So from the picture, we can see that the payload travels over a light path from source to destination. No optoelectronic conversion within network switching elements. Control information may incur optoelectronic conversion, may even flow on auxiliary electronic control network. So finally, when we dealing with the contention, we use optical buffering in time domain, and we use deflection routing in space domain. So that's all. Thank you.